In today's tutorial, we'll be looking at the simple array sum problem on Hackerrank, and we'll be looking at some Java solution implementations. Given an array of integers, we're asked to find the sum of all of its elements. For example, if we have an array with the elements 1, 2, 3, the sum of those elements equals 6. So what's an array? An array is a contiguous data structure that's used to hold elements of the same type. We have basically two types in Java: primitive types and reference types. So what we're going to do is look at how we can solve this problem, and then by using timestamps on this video, I'll be able to introduce different solutions for these problems and different ways that we can actually solve the problem. So let's go ahead and look at a Google Docs sheet on how we can approach this. So based on example, we have the elements 1, 2, and 3. So like I said, an array is a contiguous data structure, meaning that at any given time, we know how many elements are in the array. In fact, if you want to go ahead and create and initialize an array, you need to know how many elements beforehand to create an array. So we have an array here of 3 elements. We have 1 element, 2 element, and 3 elements. Next, what we need to do is we need to actually access the element. And to access the elements of an array, we start by indexing them from 0, or what we call subscript. So the first element is going to be at the index 0, and the second element is going to be at the index 1, and the third element is going to be at the index 2. So now that we know this, what we can do is we can naturally just add these numbers. So we start here with the value of the first index, which is going to be 1 in the array. We add that to the second value, which is going to be 2. So 1 plus 2 equals to 3. Now we have the value 3. So we add that to the next element in the array. This is going to give us 6. So how can we find this out? Well, we can use the built-in function within our spreadsheet, and we can go ahead and actually sum this by highlighting all of the values. And when we hit the enter button, you can see that this produces 6. So we know that the easiest way to solve this problem is to go through each element one by one, which is going to give us a linear solution, right? So the best that we can do for this problem is come up with a linear solution, all right? And how we come up with a linear solution depends on how we decide to actually access the elements. First, we can access the elements one by one, or we can try to find a clever way of doing it. So we know that we need a for loop to actually go ahead and access every single element. But one way that we can do is by having pointers that point to the back and to the front and to the back. And by doing that, we can add the first number and the last number, which is going to give us 4. And then we have to calculate a way to actually add the middle number to give us 6 total here, right? So what I'm going to do here is stop this here, and then the next timestamp is going to be for the first solution, and we're going to see how we can actually implement that. For solution 1, the easiest way to solve this problem is to iterate over each element within an array while keeping track of their sum. For this, we create a sum variable of type int that has the initial value 0. So what's a variable? A variable is a box or reference in computer programming that's used to store, manipulate, or update data as long as our program is running. Or you can say it's a space in memory. So we start with the first value within an array, which has the value 1. And we're going to go ahead and add that value to the value in our sum variable. So 1 plus 0 is going to be 1, so we update that value to be 1 now. Then we move to our second element within our integer array, which is 2. So 2 plus 1 is going to give us 3. And then we go to our last element here, and 3 plus 3 is going to give us 6. So the final result for the summation of each element within this integer array is going to be 6. So let's go ahead and look at the code for this in Java. So the first thing that we need to do is create our sum variable and initialize it to 0. For this, we can use the assignment operator, which is the equal to sign. Next, we create a for loop. A for loop is used for a repetitive task. For this, we need to access every single element within this array. So we're going to use the for each loop. The for each loop is used to access data within an array that's already filled. So we don't have to go ahead and actually index it or subscript it. We can just go ahead and create a value that's going to point to the element within that array. Now we can go ahead and add that value to our sum variable by using the shorthand form, which is going to be the plus equal to sign. So what does this actually do? It goes into our sum variable and it takes that value, it adds it to the value that we're currently looking at here. So if the value here was 0 and the value here was 1, it will add that value together, which is going to give us 1, and then it's going to go ahead and reassign sum to the value 1 now. So sum is no longer 0 but 1. So what we do next is we return the sum variable, which is going to be the return type that's given to the function here or method. So what we can do next is we can run the code and see if that passes, and you guys can see that this actually works, and then we can submit it. Alright, so what we're going to do next is look at our second solution and a way that we can actually speed up this problem. Before we move on to the next solution for the simple array sum problem, let's look at Python Tutor. Python Tutor is a way for you to visually look at your code as it executes. The step is to take your code, copy it, and paste it in the editor, and then click on the Visualize Execution button here. This can take up to 10 seconds. Once that loads, you can go ahead and step forward, and as you step forward, you can see your code visually. So here you can see that we have an array of numbers with the values 1, 2, and 3. And that array is represented on the right hand side here. Next, we can click forward, and this goes to the next steps where it jumps into this method that we wrote here with a reference to this array here. Alright, so you can see that the array here actually matches the name here, and it's referencing this array that we created and passed to it. Alright, so now that we have that, if you hit next again or forward, you can see now that we're at the sum variable with the value 0. Now we can dive into the loop, and we're at the first value here within the array, which is 1, and then we're going to go ahead and add that 1 to sum. Then we update sum, so sum is 1 now. And if we move forward, we're at the value 2 within this array here. And then once we hit next again, it's going to add the value plus 1 here, and sum is going to be 3. Alright, if we hit next one more time, we're going to have the third value in the array, which is 3. So we're going to add 3 plus 3, which is going to give us 6. And then we have to go ahead and return. So if we hit this, the value in sum, right, is going to be 6, and the return value is 6. Alright, so this is how you guys can visually look at your programs. Obviously, it doesn't work for every single thing. There are some things that it doesn't support, especially with functional programming, and it just kind of freezes. But if you're just doing letter programming and you're a beginner, this would be a nice way to understand exactly what's going on within your code. Alright, so I'm going to go ahead and step up and do the next solution. For our second solution, we want to go ahead and partition an array. We want to make sure that the loop only runs n divided by 2 times rather than n. So what we need to do is keep a left pointer. The left pointer is going to point at the first element or the leftmost element. And then from the left pointer, we can create a right pointer that's going to point at the last element. We can use the total number of elements in our array minus the leftmost pointer minus 1. The reason is because there are 3 elements here. However, the index location here is 2, right? So if we take 3 minus 0, we're going to get 3. 3 minus 1 is going to be 2. So we can use that subscript to access the element here. So let's go ahead and look at the code for this. So the first thing I do is I keep a sum variable. This is going to store the sum of all of the elements in the array. Next, I get the length of the array so that we can go ahead and do some simple math. So what we want to do, we have our left pointer here that starts at 0. The left pointer has to be less than the length, right, divided by 2, which is going to be half of the length of the array. Next thing we do is we increment the left pointer. Once we have that done, what we need to do is we need to go ahead and access the number here, which is going to be the first number within our array, plus the leftmost number. All right, so what we're doing is that we're starting at the front and the back, and we're converging into the middle, right, until the left pointer is less than the right pointer. All right, so if the left pointer becomes equal to or greater than the right pointer, and then we're going to go ahead and exit here. So what happens, for example, in this for here, when we have odd numbers, right? So here we can see that 2 is actually greater than 0 here, so we're good, right? So eventually it comes here, right? So these the left pointer and the right pointer are going to be in the same spot, so 1 is going to equal to 1 here, so it's going to go ahead and exit. So it never really grabs this value here, right? So it never adds 2 to this to the sum variable. So what we need to do is that we need to account for odd length arrays. Okay, so what I'm doing here is I'm checking the length of the array. I'm saying see if the length and 1. So what n1 does is just check to see if the length is actually odd or even. All right, so this would count the same as saying len mod 2 equal to 0. I'm using bitwise operator here, and it does equal to 0. Then we know that this checks out for even length array, so this is fine. However, if it's an odd length array, what I want to do is want to grab that middle number. So we take the length divided by 2, and then we just add that to the sum and return that. So let's go ahead and run this. And we pass, and this is good. All right, so it's good. All right, so whoever wrote this problem on Hackerrank probably did a bad job at working on this problem, because apparently all they did was give us an even length array. So if you go ahead and take this off and just return sum and run this, it should pass. Okay, and if you run it for everything else, it should pass as well, which is a problem. I mean, when I was writing this out, normally I check for every single case to make sure that it actually works, and as a programmer it's a good thing to always do that, but I feel like they made the problem so much easier by just giving us an even length array for every single thing. All right, so what I did was I just added code here, the one that I had earlier, for an even and odd array. So this would take care of even and odd array lengths. All right, so let me end this here, and then I'll go ahead and we'll look at the next solution. For our third solution, it's only fair that I talk about functional programming. Functional programming was added with Java 8 with the Streams API, and before that, almost all Java code was written imperatively, meaning that the Java developers had to implement the logic for their code and then let that logic execute and give the output that they want. With functional programming, we use functional interfaces to actually stream them together and to produce the result. The Java development team has actually created a lot of libraries that we can use, and one of the such libraries is the inStream class. So what is the inStream and the off method creates a stream of a type. In this case, we're using an int array, so the type is going to be of int array. And what this does is it creates a sequence of streams of type int, and the stream is going to contain the values within our int array here. The next thing we're doing is we're parallelizing it. So we're saying use threads to actually produce to work on the solution for this problem. And then what we need to do is we need to reduce it. So reducing means go ahead within that stream and add all of those values up and then return an int back. Okay. So you guys can see here that this is a very easy way to conceptualize what the program is doing by the use of words here. All right. So you can just look at this and you can say, okay, I know what this program is doing. So with Hackerrank, the streams classes will not get imported by default. Okay, so you actually have to go ahead and import the class before you run this program. So let's go ahead and run this, and we can see what the output is going to be, and we can see that we actually get the right answer without having to implement the logic for this. And let's go ahead and submit the rest. So for our next solution, I'm going to go ahead and show you guys what it would be like if we didn't have the Streams API to do this and we had to do it manually. I'll see you guys into the next solution. For our last solution, we'll be utilizing threads. For the sake of understanding and simplicity, I will limit the thread creation to 2. There are many ways that we can create threads in Java. One way, or the simplest way, is to create a class that implements runnable. In this class, we have an int array called Partition that's going to hold the partition for our original array. Next, we have an int field that's going to hold the sum of all of the elements within our partition. Next, we pass in an int array, partition, that's going to go ahead and initialize the partition field for this class. Next thing to do is to implement the overrided run method. In this method, we go through all the elements within the partition and we store their sum within the sum variable. The next thing to do is to return that sum variable. And back to the solution here, what we want to do is take the length of the elements within the array, which is just going to be r.length. The next thing to do is to partition the original array. There is a left partition and a right partition. For our left partition, we take the length divided by 2, and for the right partition, we take the length minus the length divided by 2. In this case, if the actual original array is odd, that means that the first array is going to have one less value to compute than the second array. However, this works because all of the values will be computed. The next thing to do is to actually fill our partition with the values from the original array. So based on some calculations here, we fill those in for the left array and one for the right array. The next thing to do is to create threads that's going to go ahead and handle running the solutions for the partitions. And remember that threads actually parallelize stuff in Java and not runnable, right? So runnables actually work concurrently, meaning that it's actually a sequential process. Next thing to do is to create 2 arrays, all right, of the simple sum thread class. And what we can do is create a simple sum thread object that takes in the left array and another one that takes in the right array. It's easier to do this way, so I just did it that way. The next thing to do is actually pass in those objects to the thread so that it can actually run the solutions for it. So for this, we just create a for loop, and then we go through each thread, and then we pass in the object that we want it to execute. Next thing we do is we execute the threads. Here, what we want to do is that we want to wait for each thread to finish working first so that we can go ahead and return the solution. So what this does is that it tells each thread to wait until all the other threads are done. So in this case, we only have 2 threads. So once both threads are done working, then we can go ahead and go to the next step here. So normally is you can pass in a value here in milliseconds and give it that amount of time for the thread to return to pass. And if it doesn't pass, then you can go ahead and interrupt. Okay. So this is why we actually throw in an interrupt exception here. The next thing to do is just to get the sum from the first object and the second object, which is going to be the left partition and then the right partition, and then you're done. All right. So let's go ahead and look at this on Hackerrank. So the reason why I was showing you guys that in Visual Studio Code was because just looking at this on Hackerrank is very messy and not clean enough for me to explain. So for Hackerrank, you have to make sure that the simple array sum actually throws the interrupt exception, and then for main here, somewhere down here, that also throws the interrupt exception as well. Okay. And make sure that the class doesn't have the public keyword in front of it. You can only have one within one file. And then you can go ahead now and run the code for this. And you can see that it actually works, and you can submit for the rest. Alright guys, this will be it for this video. I hope you guys like it, and I will see you guys in the next one. Have a good day. Bye bye.